Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we are going to discuss another topic which is important. The topic is triple products. Remember, in the last lecture we discussed dot product and cross product. We said A dot B by definition is magnitude of A, magnitude of B into cosine of the angle between the vectors. And A cross B is a vector with magnitude of A, magnitude of B into sine of the angle between the vectors. And you know how we take the angle between the vectors. We join their tails and see the smaller angle, which is particularly important in cross product. In dot product, if you take smaller angle or other angle between the vectors, it will not affect the result. So take smaller angle always, that is safe option. Now these two products involve two vectors. Now there are, in vectors we define products which involve three vectors. So we call them triple products. So first, now these triple products are of two kinds. So first, they involve three vectors. Let me write it neatly. So triple products involve three vectors, right? But there are two types of triple products. Two types. One is called triple scalar product, and the other is called triple vector product. As evident from the name, triple scalar product is called triple scalar product because the result is a scalar. As we will see, this is a scalar. And triple vector product is vector. So we will take it one by one. So let us first discuss triple scalar product. So triple scalar product. How we form it? Let us do it. This is written as A dot B cross C. So I have three vectors A, B, C. I am forming triple scalar product. You can see B cross C is a vector, then I dot it with another vector A. So resultant quantity, because dot product of two vectors is a scalar, so it's by definition a scalar. Now we want to give geometrical interpretation to it. Before that, you need to understand A cross B, this magnitude of A cross B vector is geometrically the area of a parallelogram with A and B as adjacent sides. For example, if this is my A vector, this is my B vector. If I complete the parallelogram like this, what is this? And this is this angle between A and B is my theta. So if you find this area of a parallelogram is product of base, which is length of A, into altitude. This is the altitude, or this is the altitude. This altitude is easily, you can see, it is B times sine theta, because this length, projection of B on A will be B cos theta. Projection of B on a line perpendicular to A will be B sine theta. So altitude is B sine theta. This altitude, let me use another color. This is B sine theta. So my area, that is this area of this parallelogram which I have constructed, this is A B sine theta. That means A cross B vector has magnitude, which is geometrically the area of a parallelogram formed by vectors A and B as its adjacent sides. I hope you got it. AB sine theta is the area of this parallelogram. So let us move to now triple scalar product, which we have constructed. We will give its geometrical interpretation. Geometrical interpretation of A dot B cross C. That means this thing, triple scalar product. So let us discuss it. I will draw a figure, then I will tell you what is the interpretation. Let me draw the figure. Let me do it a bit neat. This be C. Let me use another color. This is A. Let me complete the figure first. Use another color. Let me use another color. Let me use another color. This one. And this one. So my figure is complete now. Let me show the angles. Let this angle be theta. See what I have done. I have constructed a parallelepiped. This is called a parallelepiped. So I have constructed a parallelepiped. parallelopiped with A, B, C as three intersecting edges. This figure shows me, I named figure 1, a parallelepiped with ABC vectors as three intersecting edges of the parallelepiped. You can see in the figure, this is one edge, B, this another edge, C, this another edge. But they are intersecting edges, they intersect here, right? And angle between B and C is theta. Then I complete the parallelepiped. So it has 6 faces. This is lower face, this is upper face, this is left face, right face, sorry, this left face, this back face, and this front face, right? So as I said, if I find this area, let me use some color. This area of this base, what is this? This is just magnitude of B, magnitude of C, the sine of theta. As I said, B cross C is basically the magnitude of B cross C is the area of the parallelogram with the two vectors as adjacent sides or intersecting sides. So this base has area BC sine theta, which is just magnitude of B cross C vector, right? And we know this B cross C vector will be oriented this way. It will be perpendicular to the plane formed by B and C. When you use the right hand rule, it will be upward like this. Let me use this color. It will be like this. So it will be here perpendicular to plane formed by B and C. So this is my B cross C vector, right? Let angle between A and B cross C vector be phi. Let me use this blue. Let this angle be phi, right? So this is B cross C, area of base is the magnitude of B cross C, and angle between A and B cross C, we say let it be phi. Now let us find the volume of this parallelepiped. Volume of the parallelepiped shown in figure 1 is this area of the base. What is that? That is B magnitude of C, the sine of theta, this area of the base, right? Then I multiply this with what? With the height of the parallelepiped. What is that? Let me use another color here. Height of this parallelepiped is A cos phi. You can see height of this parallelepiped is A cos phi, projection of A on B cross C. Since it is making angle phi with B cross C in the figure, so A cos phi, that is magnitude of A into cosine of angle phi, is height. So this is this thing is area of the base, and a cos phi is height. So the height into area of the base becomes the volume of the parallel pipe shown in figure 1. So I can write this area of the base as magnitude of B cross C vector. Then height I write magnitude of A into cos phi, right? So B cross C magnitude times A cos phi. Now B cross C is a vector with this much magnitude. What is it? You can see from the definition of dot product. It is nothing, simply the dot product of A and B cross C. So I can write it A dot B cross C. Right? So it is A dot B cross C, vector A, right? Magnitude of vector A times magnitude of B cross C times cosine of the angle between A and B cross C, which is phi in the figure. It is A dot B cross C. So what is the conclusion? A dot B cross C is representing volume of this parallel pipe geometrically. Now, if phi is greater than 90 degrees, this A dot B cross C will come out negative. So in general, we should say that the volume is magnitude of A dot B cross C, right? In order to remove that negative possibility. What is the conclusion? Conclusion is, if I construct a triple scalar product A dot B cross C, then geometrically the volume, it is actually the magnitude of it, that's the absolute value of it, is representing the volume of a parallelepiped formed by these three vectors A, B, and C as intersecting edges of that parallelepiped. This is the geometrical interpretation. Now, since we write B cross C as determinant, I cap, J cap, K cap, then we write Bx, By, Bz, then we write Cx, Cy, Cz. So this is determinant. We can write this triple scalar product as a determinant. A dot B cross C can be written in determinant form in terms of components. Let me use another color. simple ax, ay, az. Then you write bx, by, bz. Then you write cx, cy, cz. So this is how we interpret geometrically triple scalar product and how we write it in terms of determinant. Ax, ay, az, bx, by, bz, cx, cy, cz. We make use of b cross c equal to ijk, determinant of ijk, bx, by, bz, cx, cy, cz. I hope you got the point. So let us move to now another thing, triple vector product. Triple vector product. This is written as A cross B cross C. You can see B cross C is a vector. We cross it with another vector, so resultant quantity is a vector. Now we know B cross C is perpendicular to plane of B and C. So this is my B. This is my C, for example, in some plane. Then this B cross C vector is perpendicular to C as well as perpendicular to B, because it is perpendicular to both by definition. So B cross C is, I want to establish one thing. The argument is like this: B cross C is perpendicular to the plane of B and C. You know that. Now, A cross B cross C is, let me use black. A cross B cross C is a vector, which by definition of the cross product is perpendicular to the plane of A and B cross C. Treat B cross C vector as a single vector. So by definition, A cross B cross C is perpendicular to plane of A and B cross C. We are here interested in the fact that A cross B cross C is perpendicular to B cross C. It's perpendicular to both A and B cross C, but we are interested in this portion. A cross B cross C is perpendicular to B cross C. है ना? I hope you got it. Now A cross B cross C is perpendicular to B cross C in particular. Now we combine this with this. See, B cross C itself is perpendicular to B and C. A cross B cross C is perpendicular to B cross C. Perpendicular to B cross C. So when we combine these two pieces, this piece and this piece, I will write combining these two pieces. Which pieces? B cross C is perpendicular to B and C, and A cross B cross C is perpendicular to B cross C. That means, what is the conclusion? Conclusion from combining these two pieces is A cross B cross C is some vector in the plane of B and C. Why so? Because it has to remain perpendicular to B cross C, and B cross C is perpendicular to the plane of B and C. So A cross B cross C must lie in plane in order to remain perpendicular to B cross C. So conclusion is, conclusion is A cross B cross C is some vector in the plane of B and C. So you need to understand it and remember it. So A cross B cross C is some vector in the plane of B and C. So it can be written as, therefore, A cross B cross C can be written as some combination, can be written as some combination A B plus BC, because it is in the plane of B and C. You can write it in terms of B and C as this combination, where A and B are scalars. Follow the argument. A cross B cross C is some vector in the plane of B and C, so it can be written as some combination A times B plus B times C, where A and B are some scalars. Now, when we do the calculation, we find these scalars. I'm not going to do that calculation. I will write that directly. You can see that in any book. When you do the calculation and find this A and B, you will get this. Let me use another color. I think this one. A cross B cross C is, first I write this B and this C, then there are coefficients. Coefficients are like this. I will use another color for that. Here you have A dot C. Here you have minus A dot B. This you need to remember and check it at home. So this is an exercise for you. You can use a textbook for it. I said A cross B cross C is in the plane of B and C, so it can be written as A times B plus B times C, where A and B are scalars. And I am saying this is A and this is B. That is A dot C is that scalar A, and minus A dot B is that scalar B. This is the identity. See what is the important. It is sometimes called back cab rule. Back cab rule. Because you can write A cross B cross C as back minus cap BAC minus CAB. But here A is dotted with B and A here is dotted with C. That means if you have to find the triple vector product, you can split the problem to this simpler way of calculating that. You don't need to find two cross products, which is a long process, but you find two dot products, then use this identity, you will get the answer. You will get your vector, right? So the value of the triple product is a linear combination of two vectors in the parenthesis. Now see it in general terms. The value of this triple vector product is a linear combination of two vectors which lie in bracket B and C, right? And the coefficient of each vector, coefficient of B, are the dot product of other two. See, coefficient of B is dot product of other two, that's A and C, and coefficient of C is dot product of other two, that is A and B. And of course, here you have minus. So you can check it at home, do the calculation using unit vector notation of A, B, and C. This is your home assignment. So we have done now triple vector product, triple scalar product. We know now what is the geometrical interpretation of triple scalar product, what is by definition triple vector product, and how we can use back cap rule to find this triple vector product. Let me go to next thing. The next thing is differentiation of vectors. You know it is simple. I will refresh your knowledge. Now, if we have a vector A in unit vector notation like this, ax I cap, ay j cap plus az k cap, where we know I cap, j cap, k cap are fixed unit vectors, ax, ay, az are functions of time, then we define the derivative dA by dt by the equation. dA by dt is written as I cap d by dt of ax plus j cap d by dt of ay plus k cap d by dt of az. T is the time. So you can see the derivative of a vector A means a vector whose components, this one, and this one, are the derivatives of the components. I think I write this in words. Thus, the derivative of a vector A means a vector whose components are the derivatives of the components of vector A, as can be seen from this equation. d by dt of ax becomes the x component of dA by dt d by dt of ay is its y component and d by dt of az is its z component. Now the product of a scalar and a vector and the dot and cross products of vectors are differentiated by the ordinary calculus rules for differentiating a product. With one word of caution, that word of caution is the order of the factors must be kept in a cross product. The order of the factors must be kept in a cross product. This is caution. You cannot change the order of factors in a cross product when you differentiate the product of a scalar and a vector and the dot and cross product of vectors using ordinary calculus rule. Rest is okay. So I will write some identities. D by dt of a times a is a scalar. It's just d by dt of a. Then you write a plus a times d by dt of a. A is a scalar. A is scalar. So here you are using simply ordinary product rule. You differentiate first factor, keep second undifferentiated as a multiplier. Then you differentiate the other factor and first one is kept as a multiplier. D by dt of a times a plus a times d by dt of vector a. And if you have to differentiate the dot product of two vectors like this, what you do, write a dot d by dt of b plus dA by dt dot b. This is how you differentiate dot product. A times derivative dot of a dot with derivative of b with t plus dot of derivative of a with time with b. Now, what about cross product? I said order must be kept in a cross product. Here you can write it this way or that way. You can write a here, b here. Dot product is commutative, no issue. But here you have to be cautious when you do d by dt of a cross b. What you do? Sorry. Write a cross d by dt of b plus dA by dt cross b. First you keep a as it is and cross this with derivative of b with t, then add it with the another thing dA by dt, cross it with vector b. These are some elementary ideas related to differentiation of vectors, which is required in our course. I stop here. We will continue in next lecture. Before concluding, I will give you some small homework. So homework. Question 1. Find the angle between the vectors a equal 3i 6j plus 9k and b equal to minus 2i plus 3j plus k. This first question. Then question 2. Find a vector perpendicular to both a equal to 2i plus j minus k and b equal to I plus 3j minus 2k. This homework, find the angle between the vectors, find a vector perpendicular to both. So this is all for today. Go through all the lectures, make a notebook, do all the homework, don't waste your time, and don't forget to like, share, and subscribe my channel. You can comment in the comment box. Thank you. God bless you. Assalamu alaikum.